So it is a problem based on Gram-Schmidt orthogonalization procedure. So consider four signals S1 of t, S2 of t, S3 of t, S4 of t as shown in figure. Use Gram-Schmidt orthogonalization procedure to find the orthonormal basis functions for this set of signals. Also express the same, also express the signals in terms of basis functions. So here they have given up four signals, four energy signals, S1 of t, S2 of t, S4 of t. Now we have to calculate the basis functions. We have to calculate the a basis function, and we have to express this signals in terms of basis functions. So now they are given in terms of energy signals. We have to write the same. We have to draw the same signals in terms of a energy signal. Sorry, in terms of basis signals, basis functions like phi 1 of t, phi 2 of t, phi 3 of t, and phi 4 of t. Phi 4 of t. So here, so you can see this figures. So first signals are varying from 0 to t by 3 interval, 0 to t by 3. So from 0 to t by 3 period, so the S1 of t, the energy signal value is 1. And you can see the second signal S2 of t energy signal. It extends from 0 to 2t by 3 duration, 2 to 3 by 3 period. So from in this duration, S2 of t value is 1. S2 of t value is 1. And then see the third signal S3 of t, it extends from t by 3 to t. And in this range, the value of this S3 of t signal is 1. And S4 of t is ranging from 0 to t, and the value of this signal in this range equal to 1. So here you can see that the first signal ranging from 0 to t by 3, and the second signal ranging from 0 to 2t by 3. So the first signals is compared in the second signal. So here you can mark this as a t by 3. T by 3. And then the third signal is 3 of t ranging from t by 3 to t. So here you can mark this as a 2t by 3. It ranging from t by 3 to t by 3 and t. And the fourth signals, it extends from 0 to t. So here t by 3 to t by 3. So now by looking at the signals, you can get to a conclusion that so here S4 of t, S4 of t is the sum of S1 of t and then S1 of t and then S3 of t. S4 of t is the sum of S1 of t and then S3 of t. So by looking at the figures, so we get to a conclusion that S4 of t is the sum of S1 of t and S3 of t. And while deriving a Gram-Schmidt orthogonalization procedure derivation, so I told you that so this orthonormal basis functions. So n is the number of orthonormal basis function, and m is the number of energy signals. So n should be less than m such that so they are linearly independent. They are linearly independent. So here S4 of t is a sum of S1 of t and S3 of t. So this S4 of t, the given signal S4 of t is not a linearly independent signal. It is not a linearly independent signal. It is not a orthonormal function. So you can define a orthonormal basis function for the S4 of t. Orthonormal basis function should be linearly independent. So we are discarding S4 of t and we are calculating only S1 of t, S2 of t and S3 of t. So here the S1 of t, S2 of t and S3 of t are linearly independent. They are linearly independent. So we'll consider the first signal S1 of t. S1 of t, so it extends from 0 to t by 3 and their value in this interval is equal to 1. So from the orthogonalization procedure, so we have calculated the coefficients of energy signal and then basis function. In the first signal, we have calculated the one coefficient and one orthonormal basis function. The equation to calculate the basis function, so phi1 of t is S1 of t by S11 and by setting all the coefficients to 0 except S11. So the equation 1a can be written as S1 of t equal to S11 phi1 of t. So and then so the coefficient S11 can be calculated from the equation 0 to t integration of 0 to t S1 square of t into dt whole power 1 by 2 whole power 1 by 2. So you can refer this formula from the orthogonalization, Schmidt orthogonalization procedure for the first coefficient. And here see this signal extends from 0 to t by 3. So in the formula, the duration is 0 to t. So that's why I'm changing this to 0 to t by 3. And the S1 of t, S1 square of t. So S1 of t value in this duration is 1. So that's why I have written 1 year into dt whole power 1 by t. So integration of constant is the function itself t from the so applying the limits 0 to t by 3. So applying the upper limit t by 3 minus 0 is t by 3. So under the root of t by 3. S11 is equal to root of t by 3. And then so in the first step we have calculated the one coefficient S11 by using the equation S11 is equal to root of integration of S1 square of t into dt. We have calculated that is root of t by 3. So then we have to calculate the first basis function phi1 of t. Formula to calculate this is S1 of t by S11. S1 of t is the energy signal value. The energy signal value S1 of t throughout this duration, the given duration is 1. So that's why we have taken 1 there. So S1 of t equal to 1. S1 of t equal to 1 year. And then S11, the calculated value, it is root of t by 3. I have taken here 1 by root of t by 3. So then it is equal to root of 3 by t. Root of 3 by t. So here in the problem, they have mentioned that so you have to find the orthonormal basis functions for this set of signals. And then we have to express the signals in terms of basis functions. Basis functions are phi1 of t, phi2 of t, phi3 of t are the basis functions. So now phi1 of t is equal to root of 3 by t. Phi1 of t is equal to root of 3 by t in the interval 0 to t by 3. So that is the given interval and it is 0 otherwise. And it is 0 otherwise. So this phi1 of t is written here. So I told you to draw the same for the for the given signals. You have to write the basis functions. Phi1 of t equal to in the range 0 to t by 3. Their value is root of 3 by t. Root of 3 by t. So from this value, you can calculate the S11 also, S1 of t also. And then, so consider the second equation, second signal, S2 of t. It extends from 0 to 2t by 3. It extends from 0 to 2t by 3. So by looking at the equation step 2, in the step 2, so we are making all the coefficients to 0 except S21 and S22. So then the equation is S2 of t equal to S21 phi1 of t plus S22 phi2 of t. S22 phi2 of t. Here on the signal, the given duration is 0 to 2t by 3. Given duration is 0 to 2t by 3. So the formula to calculate the S21 coefficient, S21 is a coefficient. So Sij, S21 can be written as S2 of t into phi1 of t according to this Sij equal to integration of Si of t into phi j of t dt. S2 of t and 1 phi1 of t and the given duration 0 to 2t by 3. 0 to 2t by 3 S2 of t phi1 of t dt. So now for our simplification, so I'm splitting this period from 0 to t by 3 and t by 3 to 2t by 3. From 0 to t by 3, so by writing the same energy signal and then same basis function S2 of t phi1 of t plus integration from t by 3 to 2t by 3 S2 of t phi1 of t dt. In the first integral from 0 to t by 3, from 0 to t by 3, look the second equation. So here it comprises the t by 3 duration also. Here you can get the t by 3 from 0 to t by 3. So the value of S2 of t is 1. From 0 to t by 3, the value of S2 of t is 1 and phi1 of t. So here we have calculated the phi1 of t for the duration 0 to t by 3. Phi1 of t is calculated for the duration 0 to t by 3. So that value is equal to root 3 by t. So that's why the phi1 of t value for the duration 0 to t by 3 is root 3 by t. And then we'll see the second integrals, it ranging from t by 3 to 2t by 3. T by 3 to 2t by 3, the value of the energy signal S2 of t, see the signal. So T by 3, from year to year to T by 3, the value of the energy signal S2 of t is 1. So I have taken the same year 1. And phi1 of t. Phi1 of t in the duration t by 3 to 2t by 3. Phi1 of t exists only in the duration 0 to t by 3 and it is 0 for other durations. So that's why it is 0. And here you can look here. So phi1 of t for t by 3 to 2t by 3. So t by 3 to 2t by 3. So there is no phi1 of t functions. So it is 0 there. So that's why we have 0 dt. And simplifying this root 3 by t and integrating the constants function itself and applying the limits t by 3 0. So and then the second integral, the whole term will become 0. Root 3 by t into t by 3 is equal to root t by 3. So t can be written as root t into root t and 3 can be written as root 3 into root 3. 1 root 3, 1 root 3 cancel and 1 root t, 1 root t cancels. So then S21 is equal to root of t by 3. So we have in the step 2, we have calculated the first coefficient. And the second coefficient is S22 and the formula to calculate the coefficient S22 is integration from 0 to t S2 of t minus S21 into phi1 of t a square dt under the root. Here the limits is 0 to t according to formula, but from the given signal the duration is 0 to 2t by 3. 0 to 2t by 3 and we are doing the same here. We are splitting this duration from 0 to t by 3 and t by 3 to 2t by 3. S2 of t from 0 to 2 by 3 is 1 and S21 value we have calculated for 0 to t by 3 is root of t by 3, root of t by 3 and phi1 of t in the duration 0 to t by 3. Phi1 of t is exist only for the duration 0 to t by 3. So their value is root 3 by t. So I have taken the same here. And then so for the second integral ranging from t by 3 to 2t by 3, s2 of t value is 1 and s21. So the calculated, so the s21 is ranging from, s21 is exist for 0 to 2t by 3. So there is no issue in that. S21 is equal to root of t by 3 and phi1 of t does not exist for the duration t by 3 to 2t by 3. So that's why their value is 0 here. So then it is here root of t by 3 into root 3 by t. So when you split the roots, it is root t cancels, root 3 cancels, 1 minus 1 is 0. Integration of 0 is 0. The first term is 0. And the second term here 1 minus 0 into root 3 by 2. So 0 into 1 minus 0 is 1 itself. And the integration of 1 is t and apply the limits from t by 3 to 2t by 3. 2t by 3 minus t by 3 is t by 3 under the root t by 3. S22 is root of t by 3. We have calculated the S21, S22 and then we have to calculate the basis function phi2. So here in this equation S2 of t, we have calculated S21, phi1 of t is already known from the step 1 and S2 of t is calculated. The remaining one is a phi2 of t. Phi2 of t, the formula to calculate the phi2 of t is 1 by S22, S2 of t minus S21 into phi1 of t. We know the values of S22, S21 and phi1 of t. Phi1 of t. So we'll take the values of this from the durations, ranges. So for the interval 0 to t by 3, from the interval 0 to t by 3, phi2 of t equal to 1 by S22, S22 value from 0 to 2t by 3 is root of t by 3, and 1 minus root of S21 is root of t by 3. Phi1 of t is exist for the interval 0 to t by 3, so root 3 by 2. So here the root t cancels, root 3 cancels, 1 minus 1 is 0. Phi2 of t value is 0 for the interval 0 to t by 3. And for the second interval t by 3 to 2t by 3, because the second signal exists from 0 to 2t by 3. So then t by 3 to 2t by 3, phi2 of t equal to 1 minus root of t by 3 and phi1 of t exists only in the duration 0 to 2t by 3. It exists only in the duration 0 to t by 3 from t by 3 to 2t by 3. So the value is 0. I have taken the same here and the S22 value is same, root of t by 3. So 1 by root of t by 3 is root of 3 by t. Phi2 of t is value is root of 3 by t for the interval t by 3 to 2t by 3. For 0 to t by 3, so there is no value for the phi2 of t. For t by 3 to 2t by 3, so it exists a value. And the same can be written like this. So here from t by 3 to 2t by 3, the phi2 of t value is root of 3 by t. So here we are representing the energy signal in terms of basis function S2 of t. This signal is represented like this. So then step 3. So in the step 3, so we are making all the coefficients to 0 except S31, S32, S33. And here you have to calculate the coefficient S31, S32, S33. Phi1 of t is known, phi2 of t is known, and then phi3 of t we have to calculate here. The formula to calculate S31 is S3 of t, integration of S3 of t into phi1 of t. And here the signal the third signal extends from t by 3 to t by 3 to t. So that's why here have taken t by 3 to t and split this equation from t by t through 2t by 3 and 2t by 3 to t, and we have taken the values at this. So t by 3 to 2t by 3, phi 1 of t doesn't exist, and then 2t by 3 to t, the phi 1 of t doesn't exist only in the range 0 to t by 3. T by 3, S31 is 0. First coefficient is 0, and the second coefficient S32. S32 is t by 3 to t, S3 of t into phi 2 of t dt, and split this interval from t by 3 to 2t by 3, 2t by 3 to t, and then substitute the values of this in this interval. So then you will get S32 value as root of t by 3. So then you have to calculate the S33. So S33 into the formula to calculate phi 3 of t is 1 by S33, S3 of t minus S31 into phi 1 of t, S32 into phi 2 of t. So by cross multiplying S3 of t into phi 3 of t, so we have taken like this, and we have taking, assuming that S3 of t minus S31 of t minus S32 into phi 2 of t as a G3 of t. For simplification purpose, we have taken this signal as a G3 of t. G3 of t is equal to S3 of t minus S31 into phi 1 of t, S32 into phi 2 of t. And here we have to calculate this G3 of t value for the intervals t by 3 to 2t by 3 and 2t by 3 to t. So for t by 3 to 2t by 3, so the value, so t by 3 to 2t by 3, S3 of t is 1, S31 is 0, the calculated coefficient, first coefficient is 0, phi 1 of t doesn't exist in this duration, so 0, 0, and then S32 is root of t by 3, and then phi 2 of t is root of 3, 1 minus 1 is 0 in the interval t by 3 to 2t by 3, from 2t by 3 to t, G3 of t is equal to 1, S31 is 0, phi 1 of t is 0, and S32 is root of t by 3, and then so phi 2 of t, here you can see this, phi 2 of t exists from t by 3 to 2t by 3. Here we have taken consider 2t by 3 to t. It doesn't exist in this duration, that's why their value is 0. So here 1 minus 0, 0 into t by 3 is 0. So G3 of t is 1 for the interval t by 2t by 3 to t. G3 of t exists only in the duration 2t by 3 to t. Their value is 1 in this duration. So here for this equation, we have taken this quantity as a G3 of t. So now S33 into phi 3 of t is G3 of t. S33 into phi 3 of t is G3 of t. S33, the calculation of S33, the formula for the S33 can be written as integration from 0 to t, S3 of t minus S31 into phi 1 of t, S32 into phi 2 of t square dt. So this value is equal to G3 of t. So the formula to calculate S33 from the orthogonalization, Schmidt orthogonalization procedure is this much. From this, we have equated this quantity to G3 of t. So that's why we have taken G3 of t in place of that quantity. So then G3 of t is exist only for the duration 2t by 3 to t. So that's why I have taken this. So 2t by 3 to t, their value is 1, and then so the integration of constant is t, and then applying the limits, their value S33 equal to root of t by 3. So we have calculated the coefficient S31, S32, and then S33. The formula to calculate the phi 3 of t from the assumption we have taken, assume S33, phi 3 of t, G3 of t, phi 3 of t equal to G3 of t by S33. G3 of t equal to 1 for the duration 2t by 3 to t, and S33 is equal to root of t by 3. So then it is equal to root of 3 by t, phi 3 of t equal to root of 3 by t for the duration 2t by 3 to t. And this same can be written like this. So this basis function extends from 2t by 3 to t, and the value of this function at this duration is root of 3 by t. Root of 3 by t. So here the only thing we have taken is we have assumed that this S3 of t to S3 to phi 2 of t as a G3 of t, and we have to apply limits for this, for the splitted intervals. It's very simple, you can do this.